Hello everyone. This is a solution for Evans Chapter 3 Problem 26, which is highlighted here on this page. And we're looking at using histograms, and we have a file of credit risk data, and they want us to take a look at the ages. We want to look at the ages of all the applicants here and take the range of their ages and divide it into 6 bins and derive the histogram for this, okay? So the part of the chapter that you want to be looking at is roughly around page 78 here. We have some examples. We have some data here. Here they're talking about purchase order database, and they want us to take a look at cost per order in that, and the data range from a minimum of $68.75 to a maximum of $127,500. Okay, so that's a pretty big range for the cost of the orders. Okay, so what they want to do is, when we're looking at histograms, sometimes we have in the back of our mind the Pareto approach to this, and the percentiles, the quartiles, the deciles, how many ways we want to break the data up. These are all related when we take a look at this kind of problem here. Okay, so basically we want to just use a visual. We want to develop a visual that shows us, relative to each group here, how many samples we have of the population fit in each of these bins. Okay, so for our problem they said use 6 bins. Okay, so we'll go over to Excel here, and this is the actual file, a credit risk data file, and here we have the age. We have the age of the applicant in here. Okay, so we're not going to end up using housing, years, type of job, and credit risk here, so I need some workspace, and I'm going to hide these columns. They're there. We're just going to hide them here and then build up the body of information that we need to solve this problem. So this problem started out rather innocuously. We take a look at this, and it looks fairly straightforward. A few lines. How complicated could it be? Well, that's the very problem that we ran into when we tried to solve this in the class. And what happened is this turned into a very involved problem. So let's take it all the way through. This is actually a very good problem. That's why I'm bothering to put a YouTube around this, a video around this. So what we need to do is we need to get the range of the ages that we have. Now, one thing you could do is you could grab all the data and you could sort it. And that's a good start. You could start taking a look. If you had these ages, if we had all the entrants in our data here ranked according to age, we'd have an idea of what the lowest to the highest was. We'd get kind of a visual on it. But I'm going to forego that. And what we're going to use is we're going to take a look at the maximum. Let's start with the max. So if we take a look at the max of this column, Control-Shift down arrow, I'm going to grab all those data points and close out that function. Okay, so it should bring me back up to the function again. It says the max, and I'll put a note in for ourselves here. So the max is 73 years old. And likewise, what we're going to do is grab our data range here, and we're going to lock it down as absolute cell references, because I'm going to borrow this function here. Okay, and we're going to use the min function. So just borrowing the function for a second here while I convert it over to a min. Okay, so we're going to look at the youngest member of our applicant pool here, okay, and it's 18. Let's write ourselves a note here, okay. And what is our range? Let's take a look at the range, and that's simply going to be 73 minus 18, which is 55. Okay, so we have a span of 55. And they said, how many bins do we want? They told us 6. Okay, so we're just going to put that in there. This way we can change this around if we want. If we make everything parametric, we can change that, and we can go to 10 bins, or we can go to 3 bins, or whatever way we want to do it if we write this the correct way. So if we look at the bin width, okay, sort of the bin range, how wide is just a single bin? What is that going to be? That's going to be the range of data broken into 6 bins. There's the range of data divided by 6 bins, and we get this kind of atrocious number here, this 9.16666. Okay. So not everything in life falls on even unit edges here. Okay. And what we need to do now is we're going to build a little table here, and we're going to say that the start of each range actually I'll type it here. The start of each range will be here. Here's bin 1, bin 2. We want to show the start of each of the ranges here. Bin 1 through bin 2. We can grab these two, and Excel has the intelligence when we pull it down. It says, okay, so here's bin 1 starts here, bin 2 starts here, bin 3 starts here. So where does bin 1 start? Well, bin 1 starts right at 18. Okay? And it's going to go, it's 9.166 years wide. So bin 2 is just going to simply be equal to the previous, right there, plus the bin width. Okay? So we're going to borrow this again. So what I'm going to do is I'm going to lock down the bin width here because we're going to use this a few times. Alright, so we put an absolute reference to that one. So if we drag it down, it doesn't increment. It's just going to sit there, right? And we should be able to calculate these out. And just for later use, we're going to put in here, this whole thing ends at 73. Okay, I'm just going to remember that. Okay. Alright, so when we use bin widths, these decimal places aren't too helpful. So what we're going to do is we're going to do a round of all those numbers. Okay. So we're going to round 18. We're just being consistent here. We don't need to round it. And we're going to round it to 0 decimal places. Okay, so I'm going to actually truncate or round up all these numbers using the round function here. So I'm going to drag this down. Okay, and we can even pull it down one more. Okay, so these are the beginnings of each bin, which is 9.166 wide. We just doctored it up a little bit so our numbers are just even numbers, even year numbers. We're not getting into this strange 0.166 business here. Okay, so now what we need to do is look through, count up how many applicants fit in the range from 18 to 26. As soon as you find someone that's 27, they're in the next bin. Okay, this is how we did this. So we're just simply partitioning out the range very evenly with a standard number, and now we have to go into each bin and find out how many applicants were in each of those. What we're trying to find out here is there's a slant to this. Are we getting more young people applying, or are we getting more older people applying? How does this thing work? Okay. So the way that we're going to do this, and there's a couple of lessons in here. This is going to be interesting. So we have a count. We're going to do a count if, and we're going to use our data range here. Control Shift down arrow. Okay, and I'm going to hit comma in there, and I'm going to return us back up to the top. And the criteria. Okay, so this is where things get interesting. I'll say the first thing we're going to try is just to hard code this kind of thing in here. So we want to count if any of these applicants, their age is less than this 27 here. Okay, so it's going to be less than 27. I'm going to hard code it in first, put it in quotes, finish off the function, and hit enter. Okay, so it claims that we have 121 applicants in the age group of 18 to 26. All right, as soon as it becomes 27, we're going to count them in the next bin. Okay, so for this, I'm going to lock down, I want to borrow this function again and drag it down. So I'm going to lock this down into absolute cell reference. Doesn't change the output here at all. Okay, and now what we're going to do is say how many people are in bin 2. I'm going to drag this down. It's going to be partially correct. Okay, and we want to see how many people are younger than 36. So I need to change my number here to 36. Okay, and when I do that, we have a number of 271. But what really that is saying is that's the total number of people in both bin 1 and bin 2 together. Okay, because we're taking all the people younger than 36. So to finish this off, we need to subtract out the number of people that are between 18 and 26. So we're going to subtract that out. And for future reference, I'm going to take this and I'm going to lock this down. There's a reason I'm going to do that, right? So Shift F4. F4 that, it gets locked down. Okay, so now we have 121, 150, and now we start walking down the table. We continue walking down. We have to update. The next bin starts at 46 years old. And we're not only going to subtract P10, but we need to subtract a P11 also. So what I'm going to do is I'm going to just type in the P11 as well. So there's 83 people in bin 3. So far so good. Just a little bit tedious here, just a little bit. Okay, so now we need to get the next age range. The next bin starts at 55. That's fine, but we need to subtract P12. As well. We need to get rid of P12 out of there. Okay. 43 people in that bin. Drag it down one more. We have to change this age to 64. And we need to get rid of P13. As well as all the others. I haven't been saying that, but you can see that we're deleting everything below that. All the ages younger than that. Okay, 19 in that group. Drag it down one more time. And all the rest of our actually use 74 in this case. Okay, so less than 74. We're going to do a check here. Did this come out right? Let's take a look. We have 425 entries, and we have something wrong here. We have 468, so there's a little problem here. Okay, we need to get rid of P15 somewhere along the line. We got rid of P14. We lost one along the way here. Okay, so this one's okay. This is clean. We don't have to subtract anything earlier. This one we have to subtract one earlier is P10, P11 and P10, P12, 11, and 10, P13, and this one we are just missing the P13. That was the only error in there, I believe. And that was our only error. Okay, so we've made it consistent. Well, we just calculated 6 bins worth of data here. Okay. I'm going to show you something about the COUNTIF function that's very interesting. It's not very pretty that we've had to hard code in these references. This reference to 27. There was a reason why I avoided selecting the cell and putting it into the function, and that's because this takes a very kind of unusual or special case nomenclature or format to be able to use the COUNTIF function with a text. See, when we put things in the parentheses, within the quotation marks, that means that Excel is going to interpret this as text. Okay, so it goes in there and figures this out. It has its own way of behaving that's predefined. Okay, now I'm going to take all these and replicate them right next to us here. Everything should stay the same because we had locked down the absolute references to the previous cells. So everything behaved very nicely. It came over clean. Okay, but I'm going to show you how to format this so that we can actually use the cell reference to the bin numbers or the bin boundaries here. And so for this calculation here, we would love to, for where it says less than 27, we would love to just click the cell for 27, but that doesn't work. If I hit enter, you're going to get a funny number. Now we have an error there, okay? And the actual nomenclature for this is I'm going to grab the cell reference and Control X, delete it out of there. Actually, it's going to delete it out of there, and then to actually use these, we have to append it to what's in the quotation. So this is a little bit of a disturbing format. So I'm going to use an ampersand, and put my cell reference in there. And so it concatenates less than with that cell reference, 011. And now when I hit enter, it worked. Now I should be able to drag this right down, and we should have our numbers stay the same. Okay, there's a problem there. Let's not do that. Okay, so let's try to figure out something changed. We're referencing this number here, and let's just see what happens when I dragged it down. What happened? What didn't it like? It should work. There's 012. And for some reason these numbers didn't come over. I understand now. Okay, so we're going to have to do this by hand. Okay, the reason is I'd have to go through and then subtract out all the previous cells again. Okay, right. So what we need to do is I'm just going to grab this, delete it. It's a little bit tedious. Ampersand and this cell. Actually, this cell. Okay. So nothing changed there. We are going to delete the 46 and put our ampersand in with the cell reference, which is 46. Nothing changed. That's good. We're just cleaning up the formula so that we might change things later on. This is just a more general form of the function. So I'll get rid of the 55. Put our ampersand in there and grab the cell reference we need, and there we go. Delete the hard-coded age boundary, ampersand there. Okay, and the last one here is what I'm going to do is fix this a little better. Actually, what we can do is we're going to delete that number out of there, but we're going to put an equal sign in there. So it can be less than or equals. In this case, it's a different case than the previous ones, where if it's less than or equal to 73. So I'm going to grab that and grab that, and nothing should change, and nothing did. Okay, so what I'm showing is the more general form of this, where you would love to just be referencing the contents of some cell. That's what we just did here. This is just the same numbers. This one's hard-coded, a little less elegant. This one's more elegant, and we discovered, we unveiled something here in Excel that we didn't know before, and that is we're using this ampersand to concatenate whatever inside the quotation marks with the cell reference itself. That's a little bit messy. I had to use a YouTube to actually find that for myself. That's not very common, but it existed, and fortunately I found a YouTube within a few minutes that explained that. Okay, we're all done, right? No, we're not all done. Okay, so let's go back here. What did they really want out of this? Use the histogram tool to develop a frequency distribution, which we are doing, and histogram, with 6 bins for the age of individuals in the Excel file credit risk data. Compute the relative and cumulative relative frequencies and use a line chart to construct an ogive. It's time to chart. Okay, so let's describe what we're doing here and put a few breadcrumbs in so we remember and we don't get confused along the way. Okay, so there's 2 things to compute or chart. We computed it already, but we need to chart it. Okay, and they are, I'm going to insert an arrow, and we need to plot these bins. This is the frequency table. The histogram is the frequency table. Okay. And again, fetch another arrow here, and that's going to be in relation into, we want to be able to get on our chart the age boundaries for each of these bins. Okay. But it also had this word in there, cumulative. We also want to look at the cumulative. Okay, what is the cumulative? It's something like when we do the density normal distribution density function versus the cumulative function. Okay, same underlying data, but we're visualizing it a different way. Here we're showing individual bins, the frequency or the density of each of the bins. In the cumulative, what we're going to do is for each of the bins, we're saying we start out with 121, we start out with this number, okay? And in cumulative means to add, so it's going to be the previous plus the next, and that's the combination. If you remember when we first were doing it, 271 was the number we got here before we started subtracting out the previous bin at the very beginning of the explanation here. And if we had kept going, we were going to get exactly what we have here. But we need both things. We need to calculate them different. So now I should be able to grab this and pull it right down. Okay. And so it says with each increasing bin, we add the next bin value, and then we get up to 425. So the check, we had run a check over here just to keep that in mind. That works out. These are equal. That's fine. Okay. Now what we do need, and I dropped another arrow in here, is this is the other thing. These are the three things that we have to plot. And we're going to do them separately and then go above and beyond the call of the problem. And we're actually going to show how to overlay them on the same graph using two different axes, vertical axes in a graph. So the first thing we need to do is let's put a title on here, and we're going to put age group. This is really a boundary here, and these age groups are going to be known by the entry boundary on here. This is the lower boundary of them. Okay, so the next one here would be the frequency of that bin. Within that bin, how many do we have? 121 times, right? And over here we have cumulative. Okay. So let's take a look at what we can do for graphing here. We're going to grab this to graph, and we're going to grab this to graph. It doesn't really matter. These are both frequency here, so I'll type it in again. Remember, we just did the same thing two different ways. But since this is more elegant, this column here, we're going to use that to chart. Okay, so I'm going to grab our data here. That's going to be our x-axis. And I'm going to grab our y-axis here, and we can go in and insert a graph. Okay, so we could pick one of these graphs to begin with if we really know what we're doing. But when we're not really sure, if you just let them pick the chart and see if there's anything in here that might suit us. Okay. We were told to do I think that they said bar chart or column chart. Let's go back here to compute the relative frequencies. Use a line chart to construct an ogive. Okay, so by default we're going to use a column chart for doing histograms. So click on that. Okay. That looks like a good chart, and we'll work on it once we pull it in. Okay, so there it dropped in, and there's a few things we could do with it. One of the things we could do is you could go to quick layout, and it gives you here 11 different ways you might want to format it. This is really good idea generator to run through these and just see all these different options that you might get. Which ones are easier on the eyes. Some of them have axis titles on them and some of them don't. That's a nice one. That's actually pretty technical. Look at that one. Let's click that one. I'm just going to do that. I do a different one every time just to try them out. Okay, so one of the things is to develop your own style, and sometimes in specific instances one works better than the other anyway. You might not be able to hold to a certain style. So this is our frequency, so we'll type that in there. Frequency. And down here we're going to use age group. Okay, and here we're just going to get rid of this. We don't need this guy over here. Delete him out. Okay, and one of the things is these days in Excel you can just about grab anything and you can reformat it. So if you grab these data bars here and right click on them, okay, one of the things we can do is add data labels. And that's what we'll do. We'll do add data labels, which puts their value here. See? It actually puts the value on there, so we know exactly what they are. Okay? That makes this somewhat redundant over here, but I tend to like it. It's all personal choice. Okay? One thing we might want to do, let's see how hard it is to get a chart title in here. Okay, somewhere we have to click and be able to put in a chart title right here, and we're going to put in here the histogram. Histogram of age by age. Okay. Spell it right. Okay. Got that. So that's one. We got one graph in there. That's described in the chapter. It says when you do histograms, do them like this. Use column graphs, column charts, right? Now the next thing we need to chart is we want to go by the age groups again, but we want to use this cumulative distribution, okay? So let's go see what they suggest as far as the chart goes. We'll pick the chart little arrow here and see what it shows us. Let's see what it shows us. That's pretty close to what we want. The axes are labeled correctly. If you look along the bottom, age groups. No, we didn't get the age groups on the bottom, did we? How can we get the age groups there? It did say line chart. Let's go to line. I have to work on this one a little bit. Stacked. Let's go back to recommended. Let's see what we've got here. Chart title. What's this? Oh, okay. I see what's going on. I was looking for something here. Now I understand. Okay. So what this chart implies is the points are actual discrete measurements that we're using here. It's not really a continuous curve, but we have discrete readings here. Okay, and that's why the age down here along the bottom looks like they drew it as if it were continuous. They didn't really show our bin numbers down there. Okay, so it didn't pick up on that. We're not completely done because what we've done, this is not an Ogine curve. We're still in the native dimensions of the problem, and this is the count of how many readings or how many samples we have in each of the bin. Okay, and so let's work on this a little bit. We need to edit it. I definitely want to take a look at quick layout, and I want one with the axes on there, and I like that one. That did everything the other one did. It has a title and then the axes on there. We'll just get rid of the cumulative mention here. Get rid of that. This axis is frequency. Now these are absolute numbers, not relative numbers, and down here is by age. Right? Okay, cumulative, and the one I'm putting in here, this is the ogive. Okay. It's not really quite the ogive, as I mentioned. This is still in the relative, in the native dimensions that were being used in the problem. Okay, an ogive, and we'll just name this not quite the ogive. Not quite the ogive, all right? We're not quite there yet, and I'll show you. Showing you is easier than talking about it. But there is something that we can do with this graph. And if we can work on this. Notice how it's hanging out here in space. There's a lot of extra left-hand white space and white space underneath it. And what we can do is we can go in here and edit these scales over here. And we can work on format the axis. Okay, look what pops up over here. Okay, and the first point doesn't start till like 125, so if we just put 100 in here, it's going to capture what we want. Likewise, so we're going to get rid of the lower white space here, and we don't really want to start the graph till about maybe 15 on the x-axis. So where did it start here? Do we have it? Oh, no, I have to let it go. That we're all good here. I hit enter. Right? Okay. And you can see it took away the white space underneath the curve. And now I'll select the other axes. I need to do these one at a time. I'll go in here to format axes. And instead of starting at 0, we're going to start at 15. Looks like we'll still capture. See how we move that? It's just easier on the eyes, but the audience has to be able to read these and be semi-intelligent and realize that we're not zero biasing or basing this. We're actually biasing this by getting rid of some white space. This is a much more compact graph than the other one. The other one was carrying a lot of empty space. Okay, now we're going to do this again, and there's some calculations we actually have to do. And this is pretty important to the chapter, the part of the chapter that we're working in, and to the solution of this. Okay, so this is not quite the ogive, but it's going to look just like that. It's just that our scaling is going to be different. Okay, because what we did here was, we have a cumulative here, and this is in the native dimensions. That is the count, the number of samples that we have. That's like the native metric or the native dimension for it. The native units for it. Okay, and then what we need to do is make that relative. We want to make it relative to the whole. What do we mean by that? We're going to take each one of these readings here and we're going to relate it, in other words divide it by the number of points in the total set. So 121 over 425 represents the percentage or probability or frequency in the lowest bin number. Okay, so I'll hit enter here, and so 121 represents 28% of all the points. Okay, we're trying to weight this. We're trying to understand what weight this has. Okay, all right. So what I do need to do in my function is make it them absolute. So I am going to F4 that, and that way I can just bring this down. So what you're looking at is a table of probability. You see how these numbers are increasing? These were additive, this was cumulative, and we already saw one graph. We already saw this graph of it. It's ever increasing and it peaks out at the total. Okay, so this function peaked out at the total number of points, 425. We just did a relative version of it over here, and that is the definition of the ogive. Okay, now what I'm going to do is format this data to begin with. So let's go and do that as a number, and we're only going to use 2 decimal places, which is fine by me. Okay, so there we go. And now you can, in your mind, you can convert this to percentage: 28%, 64, 83. So by the time you capture bin 4, 93% of all points have been captured by then. Only 7% remain left to be counted in. So bin 5 and 6 account for that only 0.07 or 7%. Okay, so let's graph that. This is going to be very similar to what we just did. Okay, so I'm going to grab the first column, the second column. Whoop, didn't grab it. Grab the first column. Do that again. And the second column. And now we're a little wiser about the plotting, so we can go in there and do the same thing again. Insert a line chart. Let's see, I feel better if we go through the same way we did before. We'll take the recommended. Okay, thank you very much. All right, and notice now it's the same curve, but it's just a relative measure to 1. Okay, so a lot of times when we talk about data, we just want to translate it into a standardized form, which is here we're just turning it into percentages. Okay. So what we're going to do is a little bit of an advanced chart here, and instead of having 2 separate charts, one for histogram, one for ogive, which are totally comprehensible. I mean, someone can take a look at these and understand what's going on. And if we can set it up a different one, a third chart that we'd actually use instead of these 2 different ones, sometimes your audience is sophisticated enough to be able to handle that kind of thing. What we're going to do is overlay the ogive on a histogram and use 2 axes, use a 2-axis chart. So we'll grab the information that we want, and that would be this column here, our frequency. We want to plot that, and we want to plot the ogive, and we'll let Excel will give us a suggestion here under charts. We go to charts. Okay, the very first one that pops up looks good. It's going to be a column chart in two variables. We have frequency and ogive, and then we have the bins correctly labeled across the bottom. So let's just take this and start working on it. Okay, so of course we'll do this histogram and tell the audience what we have here: histogram and ogive. Okay, so it's both of those. We'll use the key down here. They can understand the key. Okay. Now what we want to do is make a line. We want to change one to a line and leave the other as a column. So to be able to even select these little nubs that are sitting on the right here, I'm going to have to go to Format up here, and we're going to select that series, which is the ogive. We actually select it. I'm going to try to right-click that, and I have to have that heavy cross right there as the heavy format data series. Okay, and when that comes up, we're going to add in our secondary add axis. Okay, as soon as we do that, it creates an axis on the right. So what it does is it takes two vastly different series that have different ranges in them, and it adjusts the second one so that it's somewhat comprehensible alongside the first set of data here, the first series that we have. So it figured out that we kind of want to see these. We didn't want those like only almost imperceptible nubs that were sitting down here using the same scale. Just doesn't work. Okay, this is not the kind of graph where you're going to have one scale of data over here. But what we do want to do is we want to change what kind of chart type that is. Okay, so we're going to say change the series chart type. Okay, and we don't want to come over here, because if you select over here, it's going to change both of them to line or both of them to whatever. Okay, what you want to do is pay attention down here, and you can see you can change each one individually, and we're going to change the ogive to a line. Okay, we'll use a line, and now you can see that the blue bars were sitting behind the red bars. They were there, they just couldn't see them. The way they overlaid it looked like they were almost stacked column chart. Okay, hit OK, and there you have it.